And Unsaturated Hydrocarbons, Chapter 3. Preparation and properties of ethylene. Weight directly into an 8-inch test tube. 4 grams of phosphorus pentoxide connect the test tube by means of a closely fitting cork with a reflux air condenser. Immerse the tube in cold water and pour 50 cl of ethyl alcohol slowly into the condenser. The alcohol should be added cautiously in small portions and the test tube shaken under water as much heat is involved when alcohol comes in contact with the phosphorus pentoxide. Support the test tube at an angle of about 45 centigrade with the table by means of a clamp and connect it with a delivery tube arranged to collect the gas over water. Heat the tube carefully until the mixture becomes homogeneous, then more strongly until a steady stream of gas is involved. Collect then 215 cl wide-mouthed bottles of the gas and prepare an explosive mixture of ethylene and air. This can be done by placing 20 cl of water in a 215 cl wide-mouthed bottle, covering the latter with a glass plate inverted in a pneumatic throat, and displacing the water by ethylene. Inflammability of ethylene. Throw a lighted match into a bottle of ethylene. In order to facilitate the removal of the gas, a stream of water should be poured into the bottle as the gas burns. Note the color of the flame and compare with the results obtained when methane was burned. Explosive mixture of ethylene and air. Throw a lighted match into the bottle containing the mixture of ethylene and air, ethylene and bromine. Hold, add 2 drops of bromine to a bottle of gas. Replace the glass cover and shake. When the color of bromine has disappeared, observe carefully the contents of the bottle. Are there drops of an oil present? Test the gas in the bottle with moist blue litmus paper. Compare the results with those obtained with methane. Ethylene and oxidizing agents. Dissolve a small crystal of potassium permanganate in about 20 cl of water and add a little of the solution to a bottle of the gas. Replace the cover and shake. Explain the value of the test and compare the results with those obtained with methane. Test for unsaturated compounds in cool gas. Collect over water a bottle of illuminating gas. Add a dilute solution of potassium permanganate in portion of 5 cl to the bottle and shake. What conclusions can be drawn as to the presence of unsaturated hydrocarbons in illuminating gas? What are the chief constituents of cool gas, of water gas? Of what value are the unsaturated hydrocarbons in these gases? Note: when sulfuric acid, which is commonly used as a dehydrating agent in the preparation of ethylene, is employed, the reaction taking place at a temporary very near that at which the alcohol chars. As a consequence, carbon often separates the mixture forth badly, and sulfur dioxide and carbon dioxide are formed. The apparatus for the preparation in this way is described under ethylene bromide. Preparation of ethylene from ethylene bromide. Into a 6-inch test tube, place about 2 centiliters of ethylene bromide, 2 centiliters of alcohol, and about 0 and about half gram of sheet zinc. Connect the tube with the delivery tube, warm gently until reaction begins, and collect the test tube full of the gas over water. Burn the gas. Preparation of an amylene. Place in a 200 centiliter distilling flask of 25 centiliters of water, add 25 centiliters of concentrated sulfuric acid, and cool the mixture in running water. Add the next 22 grams of secondary amyl alcohol, then connect the flask with a long condenser through which a rapid stream of cold water is passing. Attach the condenser by means of a cork and adapter, the open end of which extends as far as possible into the flask. The latter is sunk into ice water contained in a beaker. Close the distilling flask with a cork. It is necessary that all corks fit tightly to prevent the loss of amylene with boils at 37-39 degrees. Heat the flask on a boiling water bath as long as anything distills. The hydrocarbon is separated and placed in a distilling flask with a little anhydrous calcium chloride. When all evidence of moisture has disappeared, it is distilled from a beaker containing water heated to about 60 degrees. The amylene is collected as before in a dry flask surrounded by ice water. Collect the product boiling from 36-42 degrees. Calculate the percentage yield and write the equation for the reaction involved. The yield should be from 11 to 15 grams. Note, the alcohol to be used in this experiment is now made by the Standard Oil Co. of New Jersey and is available commercially. Secondary alcohols of the general formula R2CHOH lose water more readily than primary alcohols RCH2OH. For this reason, sulfuric acid diluted with water can be used. If the concentrated acid is used, the unsaturated hydrocarbon is polymerized to the end 3 amylenes. Property of unsaturated hydrocarbons. Amylene and bromine dissolve 1 centiliter of amylene in 5 centiliters of camphor tetrachloride and add gradually as long as an evident reaction takes place. A solution prepared by dissolving 2 centiliters of bromine in 15 of carbon tetrachloride. Test for evolved hydrobromic acid by breathing across the mouth of the tube. Amylene and oxidizing agents. Shake a few drops of amylene with about 20 centiliters of a dilute solution of potassium permanganate prepared by dissolving a crystal of the salt in 1/2 test tube full of water. Test for unsaturated hydrocarbons of gasoline to 10 centiliters of gasoline contained in a dry test tube. Add drop by drop a 5% solution of bromine in carbon tetrachloride. Note, if hydrobromic acid is given off by breathing across the mouth of the tube. Add finally 2 centiliters of the solution of hydromer colored and divide the mixture into 2 portions. Place one in your desk, the dark, and the other in the direction sunlight. Examine the tubes in a few minutes. Explain the differences observed. Certain samples of gasoline consist essentially of saturated hydrocarbons. Other samples, which are made from the products formed by cracking crude oils, contain a larger percentage of olefins. Preparation and properties of acetylene. Support a dry 200 synthesize the ethylene flask by means of a clamp and connect the side arm of the flask with a delivery tube arranged to collect gas or water. Put a dropping funnel into the neck of the flask by means of a cork. Place in the flask about 10 grams of calcium carbide and let water fall very slowly, drop by drop, from the funnel onto the carbide. Fill for 215 centiliter bottle with the gas generator ejected. The first bottle full collected. Why prepare an explosive mixture of acetylene and thereby put 15 of water into a wide-mouthed bottle, covering the bottle with a glass plate, inverting the bottle into the pneumatic through and displacing the water by acetylene. Caution, do not let acetylene escape freely into the air. The gas has an unpleasant odor and is poisonous. Inflammability of acetylene. Throw a lighted match into a bottle of the gas. Is much soot deposited? Note the luminosity of the flame and compare your results with those obtained when methane and ethylene burned. Throw a last match into a bottle containing the mixture of acetylene and air. How does the explosion compare in intensity with those obtained with methane and ethylene? Apply the potassium permanganate test for unsaturation. Add to a bottle of the gas about 5 drops of bromine. Replace the cover of the bottle and shake. If the color does not disappear in a minute, add to the bottle a few cubic centimeters of a dilute solution of sodium hydroxide and shake. When the color has disappeared, observe the contents of the bottle carefully. Note the odor of the product formed. How could acetylene be obtained from this compound? Test for the triple bond. Test a bottle of the gas for a compound containing a triple bond using an ammoniacal solution of cuprous chloride, which can be made as follows. Heat together in a test tube or a flame a few pieces of copper oxide and metallic copper with about 10 centiliter of dilute hydrochloric acid. When the solution becomes colorless, cool decadent of about 5 centiliter of the liquid and add ammonia until the solution is alkaline. Add this solution to a bottle of gas, cover the bottle and shake. The acetylene prepared in the way from commercial calcium carbide contains impurities such as hydrogen sulfate and phosphine. If the gas is to be used to prepare other compounds, it should be purified by passing it through a wash bottle containing a solution of mercuric chloride and hydrochloric acid. It is easy to obtain an explosive mixture of air and acetylene, as the proportion of acetylene in such mixture may vary between wide limits, namely from 3 to 18% by volume. In the case of methane and ethylene, the limiting volumes are from 5 to 13% of the former and from 4 to 22% of the latter. This test applies only to compounds containing the calcium, the carbon, CH group or similar, or so on. The compound must contain a hydrogen atom linked to a carbon atom which is joined to a second carbon atom by a triple bond.